Let's get over it. So today we're doing 4.5. We are solving quadratics. You know, the big picture for chapter 4 is quadratics. We did take up a few polynomials in chapter 5. We brought those in because in a minute or next couple days we may see some of those as well. So here we go. Let's get started. There's a lot of different ways you can solve quadratics. We're just going to talk about one method today, and that's the method of finding square roots. So here we go. Oh, back up a little. No. Okay, there we go. So square roots are simply, you know what they are. Whoa, I didn't do that to me. What is the square root of 4? 2. Thank you. What's the square root of 81? 9. All right. Now, what did we do? This is all algebraic stuff. Square root of 48. How did we do that? Back here. Yeah, and you're looking for a factor of 48 that is a perfect square. You think of one? 4 would go into there. 16 would too, though. I think 16 times 3. So I could break this down into the square root of 16 times the square root of 3. Then 16 times 3 is 48. And then the square root of 16 is what? 4. So the answer to that, broken down into the lowest terms, would be 4 radical 3. With square root of 12, what's its factor that's perfect square? 4. Okay, so I can break this down into the square root of 4 times the square root of 3. And that way 2 radical 3 as its broken down version. Hopefully you remember all that from algebra 2. Algebra 1b. So if we have fractions, it's not a big deal. We can we break this up into the square root of 4 over the square root of 9. Well, what's the square root of 4? What's the square root of 9? That's not a big deal. Now, square root of 32 over square root of 2. First reaction is probably a panic because I don't know 32. Do I break that down? If it doesn't break down, what do we do? Well, look at this. If both of those are under a radical sign, a square root house, if you will, then you can put them together under the house. Oh, well, what's 32 divided by 2? 16. So this is going to square root of 16. Oh, what's the square root of 16? Now, here's a very common problem with kids do all the time. Please notice, maybe you won't forget. All right, put one thing down. Grace. Okay. Oh, there we go. All right. Here's what kids do after the speed as they go. Okay, so that's the square root of 16, which is 4, and the square root of 4 is 2. Be careful. The square root of 16 is plane 4, and plane 4 is your answer. Don't take the square root again. Yes, sir.
Wouldn't it be plus minus?
Oh, I'm so glad you asked that question. The question is, wouldn't it be plus or minus 4? The answer to that is no, and I'll tell you why. Glad you asked. We're going to get to that in a minute, actually, Joey. When you have no variables involved, it's just numbers, then the square root of 16 is 4, not plus or minus 4. Because there's no variables that I can say, oh, that x could be a 4 or that x could be a negative 4. It's just a bunch of numbers, all right? And no, none of those numbers are negative 4s. So it would just be 4 in this case. How did we multiply those guys? 2 radical 5 times 6 radical 6. Hey. What did you say? Remember, commutative order of operations? So this is really 2 times the square root of 5 times 6 times the square root of 6. We can do that in any order we want. So how about we do 2 times 6 first to get 12? And then how about we do 5 times 6 to get 30? But since these are both under square root houses, their product has to be as well. Which you can always ask, can I break that down? 30. 5 and 6, 2 and 15, 3 and 10. None of those are perfect squares, right? So I'm thinking that's as low as it can go. Even though it's a juicy number, I mean, he's got lots of factors. Just so have none of them are perfect squares. He's got lots of friends, just not for the pool. So we'll stop that there. Ooh, how do we do this? 7 square roots of 5 plus 4 square roots of 5. How many square roots of 5 do I have? I have 11 of them. This is just, you can treat this square root of 5 as if it was a variable. If I had 7x plus 4x, I had 7x plus 4x, what would you tell me that is? 11x. Okay? So don't try to put those square roots of 5 together, because you're not going to do that. You're simply going to say, of course, not working. Oh, thank you very much. Thanks for sharing that with me. I really wanted that. Oh no! Whoa! Well, I just turned it off. That's cancel. Alright. So back to this problem. Quick before it changes. 7 radical 5s plus 4 more radical 5s gives me a total of 11 radical 5s. Alright. What else we got here? There are a few restrictions. Ooh, what does restrictions mean? If you're restricted at home, that's a good word, bad word. Because you have chosen some that's not very good behavior, and your parents are going to restrict the things you do, limit, right? So there are a few restrictions in dealing with square roots. One of those is you can't take the square root of a something number. What do you think would go in there? Negative. I'm just going to keep writing. Mention close. Yes, you cannot take the square root of a negative number, at least not yet. So that's kind of a lie. That's a half truth there. But for your knowledge right now, you can't take the square root of a negative number. And you can't have a radical in the blank of a fraction. I think that would be. Where can you not have a radical in the fraction? Denominator, yeah. You'll find throughout your math career that the denominator of a fraction is so delicate. It's like a fish flower. You're very gentle. You can't have a radical down there. You can't have a zero down there. You learn other things as you get in the higher math on the denominator. And you have to take care of it every time. So let's remember, how did we take care of this? Because remember, this would break down into the square root of 2 over the square root of 5. So I do have a radical in the denominator. It's just not happening. So you know how to get rid of that radical 5? Or remembers? Anybody else remember? Times. Okay. Now, let's think about this before you just say multiply by radical 5. You don't really multiply by radical 5. You're multiplying by a 1. Because you can't change the value of this. I can't just arbitrarily go into your bank account and say, let's multiply that by a half. What? You can't just change the value of something. Now, if you have an equal sign and you have something on both sides, as long as you do it to one, you can do it to the other. But when you just have an expression like this, there's no, that is a value you cannot change. So the only thing I can multiply this by is a 1, because I can multiply by 1 all day on your bank account. It won't change anything, right? But 1s can come disguised in all different shapes and forms. The one I'm going to use is going to be, as you said, it's going to be the square root of 5 over the square root of 5, because anything over itself is 1, right? Anything. A flower over a flower is 1. Anything over itself is 1. So, and the beauty of that is, because square root of 5 times square root of 5 is the square root of 25, but wait a minute, what's the square root of 25? Go. Yeah. And then up here, I have the square root of 10. Once again, can't be broken now, so that would be the way I would get that square root of 5 out of the denominator, and now she's happy she has a little 5. She's okay with 5. Let's do another one of those. So if you had 4 over the square root of 3, 4 over the square root of 6 over 3. What form of 1 would you like to use in this problem? What's that? Well, you need to get the square root of 3 off the bottom. we're still gonna multiply by a 1. And the 4 we're gonna use is gonna match the denominator, so we're gonna use the square root of 3 over the square root of 3. Not changing the value of it, I'm just getting that square root of 3 off the bottom. Just like that. So on the top, I'll have 4 radical 3. On the bottom, I'll have square root of 3 times square root of 3, which is square root of 9. Oh, wait a minute, what's the square root of 9? Yeah. Okay, warning. Warning. Kids have a tendency to think, oh, I can cancel the 3's, right? Whoa. This isn't a 3. This is a 1 point blah. Because if you put square root of 3 in your calculator, you don't get 3. That's no 3. You see, you can't cancel that 3 with that 3. This 3 is a 1 point something. It's one of those irrational buddies. Katie, what is it? Are you looking out? Are you figuring that out there? It's square root of 3. 1.73 little bit on and on, right? So do not cancel. Just because you see 2 3s, that's not the 3 I'm talking about. Okay. Again, totally bells on you for me. All right, Joey, we're back to your question, this plus and minus thing. Now we're going to move on to solving. Now that we have the tools to work with, how do we solve quadratics? By taking the square root of both sides. So let's say we have x squared equals 4. X squared equals 4. So you would think the raw logical thing to do would be to take the square root of both sides, right? And so when you take the square root of both sides, you've been taught to say, okay, once you take the square root of both sides, it's plus or minus 2. That's what you've been taught, right? Okay, back up. Let's look at the calculator. Let's see. What is the square root of x squared? What is it? So I'm going to put in the square root. Square root. Why did I have to pack it with me? And no, I don't want that. I don't want that. Gosh, where's the square root? Do you remember? Oh, I know. This is what I want. Do that first. Okay, so I want to know, I want to plot. Clear everything. Thank you very much. Okay. I'm going to do the square root of x squared. Thank you very much. I'm done. Let's graph that. What does it give you? An absolute value. Is plus and minus 2, is that an absolute value? It's not. It's not. So this idea of just going, oh, we'll put plus and minus 4, yes, that's what you ultimately end up with, but let's talk about why. Because the theory behind this, when you get into upper level maths, and they say, why is that plus or minus 4? That's the square root. I mean, that's an absolute value. What this really is, the square root of x squared is really the square root of x. That's really what it is. Because if we use our a, h, and k, it's a vertex of 0, 0, right? That's what that is. And so really, the answer to the square root of x squared is the absolute value of x. And the answer to the square root of 4 is 4. But if you have the absolute value, excuse me, 4 is 2. But if the absolute value of x is 2, then what 2 things can x be? It can be a 2 or a negative 2. Because the absolute value of both of those are true. So that's why your answer is plus or minus 2. It's because of this absolute value piece. And you probably have never been shown that before. You can handle it before. But now now you know what actual values look like in the graph. And I took that and then be able to prove that to you. So that's why you get the plus or minus 2. And you only get that when you're taking the square root with a variable under it. Like Joey pointed out earlier, if I just said what's the square root of 16, you don't say plus or minus 4. So I'm looking at the variable. Okay? All right. So, really, x squared equals 4, and you take the square root of both sides. Square root of x squared is the absolute value of x. Square root of 4 is 2. And then what two things can x be? Plus or minus 2. That's really the progression of what you're doing. Most of you, though, skip from here to here. And honestly, you'll be skipping it in here, too. I'm not going to make you write this piece in every time. I just wanted to show it to you and prove that to you. All right. So, yeah, we did that as well. That's the same kind of thing. So here we go. So let's start solving something. So we have 4x squared minus 9 equals 0. And I want to know what can x be to make that a true statement. 4x squared minus 9 equals 0. So I'm going to take the 9 to the other side, because I noticed that all of these numbers are squared, right? Then I'm going to divide by 4, because I want to get the x squared by itself. So I'm solving for x. And now I'm going to take the square root of both sides. Here we go. I would normally say mathematically say that's the absolute value of x equal 9/4. But what is the square root of 9/4? Square root of 9. 34. Right. So that means x then is plus or minus. About 3x squared plus 5 equals 41. 3x squared plus 5 equals 41. Again, the goal, I'm trying to get that x by itself, that x squared. So you can take the square root. So what would you like to do first? X squared equals 36. What would you like to do? Yes, sir. Now, x squared equals 12. So once I've got the x squared by itself, I can take the square root of both sides. Again, it's the absolute value of x there. 12 breaks down into what? 4 and 3. So x then is going to be plus or minus 2. And I think we talked in this class before about how if this is your highest exponent, what do we call the highest exponent? It's the blank of the polynomial. It's a D word. The highest degree is oh, we just said it. The highest exponent is the degree of the polynomial. And that's how many solutions you need to have. So this guy needs 2 solutions. Well, I got 2 solutions. A positive 2 radical 3 and a negative 2 radical 3. All right. 3 is 120. 5x squared equals 36. Do this one. Do not turn this into a decimal. What's the problem with that answer? Can't have that radical on the bottom. She's lying. Get out of here. That's easy. So what are we going? What form of 1 are we going to by? So really my answer then is going to be 6 subtract 5 over 6 subtract 5. Oh, but holy moly. When we write that answer, Oh, that's good. That's all I can do, because I can't reduce it. No, we're good. So I've got 2 answers, because I had second degree polynomial, I gotta have 2 answers. Got the idea? Pretty easy stuff. Let's see, what if we have something with parentheses like this? What's this gonna do to us? The goal's still gonna be the same. I wanna solve for x. Well, no, we're not gonna distribute. Because this exponent has to be done before you distribute, if you're gonna distribute, but we're not gonna distribute. Remember, we wanna get this piece by itself, so how can we get rid of the 2? That's right. I don't wanna spread the 2 around. I wanna get rid of it completely. Oh. Well, if this whole binomial is squared, then let's just take the square root of it. Because a square root and a squared are opposite operations, like a plus and a minus. If I add something, subtract something, the same thing, get back where I started. So by square rooting a square, the x minus 5 just falls out. It's going to be plus or minus 2. We're going to add 5, so x will either be 5 plus 2, or x will be 5 minus 2. Brain's already going to the answer. So my 2 answers are 7 and then 3. And notice I did not leave this problem in this form right here, or this form right here, because this plus or minus 2, I need to go in and work that out if there's a number here. It's 7 and a 3. Where's this last answer? Or plus or minus. I can't work, there's nothing to work out there. So I can maybe just use plus or minus. Let's see if anything tricky. Yeah, it's the same thing. We figured that, right? Add a 5 to both sides first. Divide by 2. I'm going to use for those at home real quick. So I'm going to add 5. Divide by 2. Alright. You don't like it, but we can do it because we're big people. And then we take square root of both sides. So x plus 2 falls out. And this becomes plus or minus radical 13 of radical 2. Oh man, she doesn't like that radical 2. Oh man, who says that on Dora? Swiper, that's right. Oh man. Until I have red arms. Oh yeah. Oh man. Right. So how are we gonna get that square root of 2 off the bottom? Yeah, we're gonna multiply by 1. The size is the square root of 2 is 2. So we have x plus 2 equals plus or minus. Radical 13 times radical 2 is radical 26. 2 times 4, radical square root of 4 is 2. So finally I'll end up with negative 2 plus or minus radical 26. 2 answers. Quadratic. And that's all I need to say. That's all I got. We good with all that?
Yes,
Okay. And here you go.